I apologize for the writing today because I'm going to have to write with my finger because my Apple Pencil is missing. But, all right, so what I'm going to do is just go through the idea of linear rules. This is very simple, but you must pay close attention to what you're doing to make it work every time. Okay? All right. So first thing I want to do is I want you to tell me if you have a multiplier. That means some number that you're multiplying with, right? Okay? And if I have a number right in front of a letter, what operation does that always indicate? Multiplication, exactly. All right? Then we also can add or what? Subtract. Okay? So that's what we're going to do is to get these rules. Okay? So the first thing we're going to do is we're going to have a list of values. And they can be distributed in a couple of different ways or given to you in a couple of different ways. We can have them in a table, which we've seen before, this table where we have numbers, where n stands for the number value. So if it's the first one, the second one, the third one, the fourth one, etc., right? And t is from just a list of numbers. So say we have 2, 4, 6, 8, ... What does that ... mean? Ongoing. It goes on forever, infinitely, right? So in this particular sequence of numbers, what is the first number? 2. So the first number is 2. You see that's the way that's working? The first number and then the number itself. What's the second number? So the second number, so the one that goes with 2, is 4. What's the third one? And finally, the fourth one? 8. And then they could continue that way infinitely. No surprises there, right? So this is the first, the second, third, etc. So if I'm asking you for the third number in a sequence, is that an n value or a t value? N, the third number, fourth number. N always indicates the position of the number. Does that make sense? All right. Whereas t is the actual value itself. And what we're going to do is we're going to look at a rule that will allow us to write an equation. How do you know something's an equation? The equal symbol? Good. We're going to be able to write an equation that's t equals an plus c. Now, n, I just introduced from the table, right? That's the position. T is the value that you're going to get when you do that math. And A and C is just what's called general form so they're just some numbers. We just don't know what they are yet, right? But if you have A in front of the C, that means A is the multiplier for the C, right? And then you have the plus C, but that could just as easily be minus C, right? If you're subtracting something, it wouldn't be plus, it would be minus. But usually in general form, we write plus to stand for both of them, okay? So what we're going to do is we're going to look at some patterns, and we're going to be able to write this rule. And all of the rules will look like this. T equals something times n plus or minus some other number. Okay? Which looks very familiar. This is the gradient formula, isn't it? Except you would have m in front of your x. Right? So this is where this all starts, where this all comes from. And we're going to use the difference rule to find it. Now this difference rule works on all linear patterns. What does it mean if it's linear? If you graphed it, it would make a straight line, right? So any of these would make a straight line. So they work on all linear patterns. So we're only going to be looking at linear patterns. And the steps are quite easy. First, what we're going to do is find the common, it's not as easy as it looks, writing, of the t's. Now, is t the top number or the bottom number? It's the bottom row, right? Okay, find the common difference. What does difference mean, and what operation is difference in mathematics? Does anybody? Come on. Subtract, you bet. Yeah, so we're subtracting. And what you're going to see is that if you subtract them, they're always going to be the same number. Right? So let's go back to our pattern that we just looked at. So our numbers are 2 and 4. 4 minus 2 gives you what? 2. 6 minus 4 gives you what? 2. 8 minus 6 gives you what? 2. So as long as the numbers are side by side, when you subtract them, notice we keep getting the same number over and over and over again. Okay? And that's called the common difference. Okay? That common difference is your A. In other words, the multiplier. Remember I had it as A to the A times N? Well, that gives you your A. That's your common difference. Okay. So I could write this rule as T equals, what is my A in this case that we just did? 2. 2 times N. Using that formula, that general form of the equation. Now, but what we have to do then is test to see if there is some value for there. Not all of them will. As a matter of fact, this one's not. It's going to be, we're done with the pattern. But that's not always the case. So what we'll do next is step 3 is test on n equals 1. And we always choose n equals 1 because it's easy to multiply with 1, isn't it? So that's the easiest one to test with. So let's just go into the page ahead and I'll come back to the directions there. So we had t equals 2n with our common multiplier. Of course you may. Okay? And remember our pattern was 1, 2, 2, 4, 3, 6, etc., right? Just to remind you of what the table looked like. So what I'm going to do is test n equals 1, which simply means replace the n with what number? 1, and then work out the math. Well, t equals 2 times 1. Remember, you never replace a letter without putting it in a parentheses, which gives you t equals 2. If n was 1 in your pattern, was t 2? Yes. So that checks out, doesn't it? Which means that's my pattern. I'm done. Okay? Now, they don't always, though, just have that simple a pattern. Sometimes there's more to it. You'll be adding or subtracting more numbers. So, let's look at another pattern and see what we have to do in that case. Again, it's based on the rule of differences, so you're going to be just finding the difference, right? So, say for example, we have our table. And we have n's, we have t's, we have the first, second, third, and fourth. Say this is 3, 5, 7, 9. Okay? So, we want to find a rule for it. So the first step in finding the rule is to what? Find the what? Common difference of the t's. Okay? So, here are t's. So we take 5 minus 3, and if you do them, and you're finding the common difference of the side by side, and we take the biggest number. So 5 minus 3 is what? 2. 7 minus 5 is what? 2. 9 minus 7 is what? 2. Do I have a common difference? Yes. If I didn't, what that tells me is that this pattern is not linear. But all the ones that you should have are going to be linear. So that gives me the first part of my pattern. It's t equals 2 times n. That's not always going to be 2, by the way. Now, the next step is to test that on n equals what number? 1. It's always going to be, you're always going to test it on n equals 1. So t equals 2 times 1, which gives me t equals 2. Okay? So that says that if n is 1, what should t be? 2. But look back at your chart. If n is 1, what should t be? 3. So my pattern is not finished. There's going to be something else to do. And again, it simply means using another difference. To find the other one, so we need to find our c. Oops. Let me do that again in black. To find c, which is that number at the end, right? Okay, to find c, simply subtract. All right, so why do I say that this pattern is super easy? Sure.
Because we're just multiplying each number by 3?
Exactly. Because the pattern is simply 3n, all you're really doing is multiplying every n by 3. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 12, 10 times 3 is 30. So do you see that once you have the pattern, it's very quick and easy to find all of the numbers in the pattern. Okay? Just follow the rule. Now that one is pretty simple because it just had 3n. But most of the time, they're also going to have other values attached as well. Okay? All right. Okay. So here's one. Let's find the rule for it. The numbers are bigger, so does that mean we need a new rule? Nope. The rule stays the same. First thing we need to do is find the common difference. So that we just find by subtracting. 14 minus 11 is what? 3. 17 minus 14 is what? 3. 23 minus 20 is what? 3. Notice I was jumping around a bit. And as long as you pick numbers that are side by side, it doesn't matter. Pick any ones you want. But you notice that our common difference in this case is the 3. So we know that t equals 3n is the first part of our pattern. But we need to see if it's all of our pattern. And the way we find that is by testing. And what do we always test? N equals what? 1. It's the easiest one to test. Always just use 1. So t equals 3 times 1 gives me t equals 3. Is 3 the number, my first number in the pattern? Nope. But all I have to do then is do the difference between these two numbers, the first number in the pattern and the number and the test number that I just got. So I'm going to just do 11 minus 3, which is what? 8. And since it's positive 8, that means I need to be adding 8 up there. How happy are we with the easy lessons? Pretty happy? Tired? How can you be tired? You're too young.
I just want this time to be over.
I'm gonna go get tan on the beach and go swimming.
Okay. All right. Hold on. All right. So that's what we're going to be doing is finding the linear rules. They may get bigger numbers. You may asked to use the rule, but you're not going to be asked to do anything any different than simply finding these rules. Okay? Now, What if we're giving the rule as a picture? Will that be harder? No. All you're going to do is find the first one. So this is the first one. Right? This is the second one. This is the third one. This is the fourth one. So the first one has how many matchsticks? 5. So it's 1 and 5. The second one has 1, 2, 3, 4 more, so 9. So all you really have to do is count out the ones they've already used, right? And the next one's going to have 4 more. Whoops. So the third one is 13. So do you see that? You already know the common difference by the number of new matchsticks. So it's going to be T equals 4N. Right? So you can find them using the patterns. Using pictures as well. So you'll be doing some of those. All right? Okay. Stop that.